Okay.
Okay, I think it's recording, though I don't see evidence of that on the screen.
It's not showing.
Yeah, it says it's recording.
Okay.
All right, so what I have is my NLCD data, and I'm just pulling out a county so that I have a small study area.
Okay.
And then you'll have like a watershed or something, or whatever your unit is. It doesn't matter, but
Yes.
that's how I'm gonna do it here. So I got like a file that's the whole country, so mine's gonna go slow for a second until I let's check. So I'm gonna do mine for Jefferson County. However, what I was hoping somebody would be interested in is if you have the data for the whole extent, you know, and your question was like, how does this, this particular watershed and all of its practices and layouts and whatever, how does it differ in terms of your model output? How is this watershed different? You know, for any one step in time would be interesting, but then if you kind of ran it over time, it'd be, super fly.
Yeah.
And I don't know that your model really allows for it because of the way the parameters are aggregated, but maybe it does. Uh, okay, so let me just turn that guy off. So I got NLCD there, and I'm just
Okay.
going to crop that guy out. Just so that it's smaller here. And I'll leave it. All right, so that'll take a minute to run. All right, so we're after NAEP, right?
Yes.
We're after NAEP. So all of the NAEPs are stored in two shapefiles from KY GeoPortal. You probably have them already.
Yeah.
Uh, Let's just put in NAEP index, see if that works. Yeah, so there's two different tile indices. One of them's called the 20,000 and the other is 10,000. How they decided what was what, I'm not sure, but what it means is that the some of the NAEP years are stored in one and some of the years are in the other. But this allows you to download all the years for any area that you want. All right, so you see what I got?
Yes.
All right. So let's just jump into, hold on just 1 second. All right, so I have 2016 land cover. So let's see. I already forgot what those things were called. Oh, Kentucky 20K. All right, let's check this one out first. The 10K. Uh-oh. All right, because Jefferson County is a border state, right?
Hmm.
So to cover the whole county, I need a ton of tiles. A ton of tiles. How many tiles do you need to cover your watershed?
It's larger.
Larger?
Yes.
Woo, okay. So if you set up in Model Builder a process for each tile, you simply just loop through each tile. So that's not a problem, as long as you can build a model
Yeah.
in it, which we can do, because you don't actually need the okay, so I don't think size matters here.
Okay.
Except the download is going to be terrible. So let's say but you're only in Kentucky, right?
Yes.
All right, only in Kentucky. So
No, actually, some parts of Tennessee as well.
well, the NAPE imagery for Tennessee will not be available here. It's only for Kentucky. But Tennessee has a lot of stuff available, including their own NAPE. And here's where you can find it.
Okay.
All right. And if you can't locate it, I'll help you dig up whatever you need.
Okay.
All right. But anyway, hopefully it's in an index or something. So now all I need to know which tiles I need, right? Which tiles I need. So the ones that intersect Jeff County. All right. Oh, but hold on. Let's look at NAPE here. Let's look at it real quick. So my Zoom's interfering. Can't grab it and move it. All right, so these are the ones I selected, and what does it give us? We got 2006, 2016. Okay, and in the other one, there'll be like 2003, 2008, 2011, all the other years, right?
Mm.
2018 rests on its own. It's got its own layer, but they don't have it in an index like this. But 2016 is the year that we want, right?
Yes.
And let's see, where is that one? Okay, that one's in a good area where there's a lot of change. So whichever one you like, as you know, and I can show you how to use R to download all these guys real easy.
Okay.
But all you got to do is just, the attribute is the website, right?
Yes.
So I can just like copy that directly and search for it. And then there's the file.
Yeah.
And it's tiny, it's only
Yeah.
3
Okay.
megabytes, which makes you wonder why they did it like that. Why not give us 100 megabyte files that cover bigger areas? But what are you going to tell them? So that's it. So I need to look. 34, 118. 34, 118. 34, 118. 34, 118. Right there. All right, so there's an area, right?
Yes.
All right, let me go ahead and save this guy. So this is where you're at, right? You basically have this already, and you have a land cover map that you're happy with, right?
Yes.
All right. So let's move you back over here. Let me turn these guys off now. Oh, that's my clipped one. Uh-oh. Damn, you see what happened? Let me, I need a different tile. I need a different tile. I need a different tile. I want some water in there. Let's, I'm gonna use this tile. I'm gonna use that one instead. Let's get rid of that guy. And let's go back here. And that one I have selected. Let's go back here.
For 1, 1, 2, 3.
41, 123. 41, 123. 41, 143. 41, 143.
It's down.
Is that it? 123?
Yes, 4, 1, 1, 2, 3. That's the one.
All right. All right. So that's cool. There's some water in there. There's some other stuff. And it should match pretty close to for the land cover there, though. Looks like there may be some. Yeah, that's really good. The streams are marked. They call it wetland up here. Okay, but it doesn't really matter. All right, doesn't really matter. So let's just clear out. And so my study area is now this guy. Okay,
Yes.
to that extent. So okay, and we have land cover data that we're happy with.
Yeah.
Let's see, we should be able to do something with the symbology here. It's stored with it somewhere where you can turn the labels on the right way. But anyway, the numbers are fine, right? You know that 11 means whatever and 21 means whatever.
Yes.
But you have fewer classes, right? You have fewer classes than I have, but it's you know, it doesn't matter. It doesn't matter. So, okay, so first thing you want to do, since this is classification, is the input data is going to be the NAIP. And now you just need to give the classifier some labels so it knows what is what. So let's, now there's always a lot of routes, right? There's a lot of ways to do things. So, but one of my favorite ways is random points. Okay. Random points. And these are just what? These are samples, right? And the constraining class is, uh-oh, it won't let me use the raster. Won't let me use the raster. Let's, I mean, all right, you probably have a square or something as a study area. So let me just make something like that. And I'll just take the county and cut it to, Oh no, you know what? I don't have to do that. Let me go back to what I was doing. Random points. Create random points. Because a constraining class, if I select it, now the constraining class can be the 10K. All right.
Yeah.
So the selected part of the 10K, that's my constraining class. Outputs, still called samples. All right, so how many? There's a formula that says, you know, like 30 or 100 times however many or whatever. I don't know what that number is, but for fun, I'm just going to say 300. And you can say how close they can be. So I'll have 0, but chances are one point can fall right on top of the other point, you know,
Yeah.
or whatever. Since you have whatever meter data, I think NAEP is 1 meter. But anyway, so that's it. So let's just run that and see what happens. All right, so there's all those points that fall in there.
Yeah.
Now, okay, so now you can just do value to point, extract values to points, extract values to points, and the input points are the samples, and the raster is my, let's see what I name. Well, I guess they're both the same, so it doesn't matter. But that one just says 201. Here, this is my clipped NLCD,
Okay.
my NLCD. And it looks like it wants to create a new shapefile. So it's just going to be samples, and I'll add NLCD. All right. And so here's an interesting thing. You have an option to interpolate values at point location. If it were something like modus NDVI, and the point fell kind of right on the border of 2 points, then it would interpolate from centroid to centroid,
Yeah.
right? Instead of just using the exact square of the pixel.
Yes.
In some ways, it's more realistic. In some ways, it's not. You know, the data is whatever it is. So, but that can be handy if your data is continuous. It'll interpolate these values too, because they're like 11 and 12 and stuff like that. So it'll give you some 11 and a halves in there, right? But it wouldn't mean anything, not for nominal data that we have. All right, so let's just run that guy and see what it gives us. It's here, let's just look at it real quick. So for every point then, it gives us whatever the raster value was. So those are forest, and that's an urban, and these are forest, and that's another urban, and there's a crop. You see?
Yeah.
And if we wanted, we could let's see, the symbology, we can do that according to the raster value, for example. So now they're colored according to you know, whatever they are. All right, so that's half of it. So that's the labels, right?
Yes.
So in R, you're pretty much ready to go already.
Okay.
Now in here, so now if you wanted to get the you're gonna do your classifications, you want to do everything in
No, reclassify. I think it's reclassify a bit better. Okay, so these random sample points are similar to like training samples which you take in another method.
It's exactly that.
This is pretty fast.
It's exactly that. It's exactly that. So what this saves you is from having to have gone through and did whatever. So now you have training data. So now in so
Yeah.
you know, now you sample the layers,
Yes. Yes.
and you could make a linear model that says band 1 plus band 2 plus band 3 equals land cover class, right?
Yeah.
It's it'll be more rule based. It's not a continuous, but in terms of calculating the probability for it, because you'll see you know, you'll do your band statistics and just see. So you could just set up rules, right? Like if urban has well, let's just see what it looks like. Let's just see what it looks like. So now we want to see what these look like. So what do we got to do? We got to do well, you can do multi-value to raster again. Say multi-value to raster. No, a multi-value, just multi-value. Multi-values to points. All right, because each value is one layer. So land cover was one layer, but this image is 3 layers.
Yeah.
All right. So let's check this out. Let's so this is our image here, and we can hit that little arrow and access the bands individually.
Yes.
So let's all right. So I got bands 1, 2, and 3 up in there. And you've looked at that, no problem. So, you know, already in terms of your classification, let's see, what are we looking at? Here we're looking at blue. This is blue, right? You could almost make a rule that just uses blue and extract out agricultural managed land from forest. Could you not? And you wouldn't even need a heavy classification tool. You could just say, if the blue value is bright, it's agriculture. If it's dark, it's forest, right?
Yes.
So I mean, you could just set like a one rule, a raster calculator. You could use raster calculator that says, just show me the values that are above whatever. But we
Yeah.
don't know what that value is yet. Okay, we
Yes.
don't know what it is. But the same goes for green. Green's never as helpful. Okay.
Mm.
And then red's always pretty helpful, because red is great for brightness. So nothing ever looks this bright except for, you know, exposed minerals, which is either soil or polished concrete or stuff like that. You know,
Yeah.
look how great your roads stick out.
Yes.
Now the plants, they're dark, right? Because they're using all this energy that's falling to do photosynthesis. So even though you can't calculate NDVI because we don't have the near-infrared image, you don't need it, right? Not to just know whether they're doing photosynthesis or not.
Yes.
So the farmland is using some of it. Even though it's early, the soil's absorbing that energy, but the man-made structures are not, right? So on in red band, only the really bright stuff is mineral, dirt or concrete, right?
Yeah.
So again, raster calculator could be used right here to just extract out where red band is greater than whatever.
Yes. Yeah.
So you could use raster calculator in a couple creative ways and not even have to do statistical classification. You see?
No.
Especially when you have those real simple only 4 classes. Maybe you just need 2 or 3 rules. But anyway, we'll look at that in just a second. We'll look
Okay.
at that. Let's just keep going. So now we got those bands, okay?
Yeah.
And there's probably a way you could sample it just by handing it this one, but it'll only, for me, it'll only sample the first one, okay? So I had to add all these layers, you know, to be able to sample them in the way that I'm showing you. So, okay, extract multi-values. Okay, so give it the samples again with NLCD. And then let's give it band 1, band 2, and band 3. Red, green, and blue. And then we can even label them here. Red, green, blue. If they were big old pixels, like Modis pixels, you know, this would be a great time to do the interpolation. You know, but our pixels are so small that we don't need to, because our imagery is like, oh, that's something else to keep in mind too. We're using NAPE imagery that's at 1 meter, and we are sampling it into 30-meter training data. So what if our point falls in a forest pixel but falls on something urban in that pixel? So we might even want to go back one step and aggregate this up to something closer to match that 30 meters. I don't know. But anyway, let's just keep going with this. You see the problem with the mismatch though, right?
Yes. Yeah. Some of them are overlapping.
Somebody's going to say something. So the solution is either is to simply aggregate your 1 meter imagery, aggregate it into something that's a little more coarse. Or maybe you won't have that problem at all. I don't know. We'll see. The other issue is because our points are randomly scattered, right? There's a bias. So whoever is overrepresented in the model, they're going to be overrepresented. So the model is going to want to call everything forest if your whole area is forest.
Yes.
All right, so let's see what we got here. So here's what we got now. We got a curve basically, right? Curve, a signature. So you could, so from here, let's say accidentally selected. You can do something like summarize. How do you summarize? Summarize. Output table statistics. Okay, the case is the raster value, and the fields are red. We'll say mean for now. Green and blue. So the means. So the means. So now here, this little table here are your curves for each class. For each class. So that's how many people in the class. So there was only one water, for example, and that's what it looked like. This level of urban, this is what it looked like. So what we could do, we could visualize that. Somehow you can visualize it in Art Pro, but I'm just real quick gonna spit this boy out to my desktop. And I guess TXT will be okay. So what if I go here?
Advanced text. Okay, those values are here.
No, that's not what we wanted. Well, all I'm trying to do was try to show this for each one. I don't know how to add them one by one. But anyway, that's what your lines look like. Your curves, right? Your spectral curves. So now you just need a model that says, you know, mathematically how these equate to this guy. Right? So now you're ready for like a supervised classification.
Yes. Like we have these training samples and 3 bands. Is it also possible to like stack those bands and do supervised classification?
Yeah, that's what we're about to do.
That's what I think.
Yep.
What in my
Yeah,
mind.
so it's like so you can create signatures, and that's kind of what we did. And here you could have did it and draw like squares. So it's kind of a wizard for that. So let's see what we need for your supervised classification. Maximum likelihood. Your signature file. So in what form does this have to be in? Use file the maximum.
Again, if we don't add.
Yeah, maybe yeah, so maybe we should have kind of went this route. So our feature sample data will go back to being samples in LCD, input raster bands, band 1, band 2, band 3. Sample field is raster value. I guess just run that.
I've got one interview on 11:30. I don't know how to say to you.
Yeah, well, we can you know, we can come back. That's no problem. Training features. So that would be here. And then the variable to predict would be that guy. Tree category. Yeah, we'll actually just have to go through it and see,
Yeah.
and just see. So I think this is the way here. We may need to just look up a tutorial real quick to get that. But yeah, go get your other meeting. That's fine. We'll come back whenever you're ready.
Yeah, it's an interview for one
Yeah,
was fun, so
do your thing. No problem. We'll just save it and come back whenever.
okay, thank you
All
so
right,
much.
yeah, good luck.
Yeah, I got her email at middle of the night, so she gave me the time.
Yeah,
At
no problem. No problem. No problem. We'll see.
okay,
All right.
thank you so much. Now you can save this video.